Section 4.7, Optimization. You can find this worksheet on Blackboard under Section 4.7. Please download it and follow along. Optimization problems boil down to finding extreme values that have practical applications. Our biggest challenge is converting the situation into a mathematical relationship to be optimized. Let's look at an example. A farmer wants 2,400 feet of fence that he wants to use to fence off a rectangular field that borders a river. He needs no fence along the river. What are the dimensions of the field that will give the farmer the largest field? Here's my solution. Step 1. You need to understand the problem. Read it more than once. It's very important that we usually go back and read the problem a couple of times to make sure we understand what's happening. A farmer wants 2,400 feet of fence that he wants to use to fence off a rectangular field that borders a river. He needs no fence along the river. What are the dimensions of the field that will give the farmer the largest field? What is the unknown? The unknown is the dimensions that will give the largest field. What are the given quantities? The farmer has a total of 2,400 feet of fence. It also needs to be a rectangular fence, and there's no fence along the river. All of those things are given to us. Step 2 is to draw a picture. Sometimes it's hard to draw a picture, but in this case we can. Here's my river, and a fence is being built in a rectangular fashion on the river. Step 3 is make notation. I made the notation for the parts that run perpendicular to the river of y, and the part that runs parallel to the river, that fence, I called x. Step 4. Substitute to make a relation of one input variable. I know that the area of this rectangle is x times y. Length times width, that's the area. I also know the perimeter of this particular rectangle is 2y's plus x, and that has to equal 2400. The perimeter of the fence that I have available is 2y's plus x limited to 2400. Then what I did is solve the perimeter equation for x and substituted that into my area equation. So I have area equals 2400 minus 2y, 2400 minus 2y, that equals x, times y. We need to maximize this because that's what we're being asked to find, is the maximum area. How do I do this? Well, I find the absolute max or min by taking the derivative of the area function with respect to y, setting it equal to 0, and then solving for the variable. When I do that, I got y is equal to 600 feet. I also need to find x. So I plug the value for y into my perimeter equation. I plugged in y equals 600, and I get 2 times 600 plus x equals 2400. 2 times 600 plus x equals 2400. Solving for x, I get x is equal to 1200 feet.